Morning, everyone. You should be able to see three of us now.
Morning.
Morning.
We've got a double act coming up now from Andy Brunskill and Phil Spooner from SA Partners. SA Partners have spoken at our events before. They've got a lot of experience, written books about TPM, so there's not many people who are as experienced as these guys, and a lot of case studies that they've done in industry. But particularly this is around the use of TPM and asset management. I'm sure you'll find it a really interesting presentation from two of the most experienced people who've been working, in our industry and other industries. So I'm sure you'll find it extremely insightful. And I'll get out of the way and let Andy and Phil do their job.
Thank you very much, Felix. So hopefully everybody can see our slides, and thank you very much for joining us today. In real terms, we're going to talk about asset management in different environments, how you apply that. So a bit of quick introductions. My name's Phil Spooner, my colleague Andy Brunskill. Andy Brunskill is our global lead on TPM. He's actually the co-author of one of the major books in the industries, which is called Links to a Foundation of Operational Excellence. And I'm fantastic that you can actually join us today. A little bit about SA Partners, why we exist. Really, we're about helping businesses become as good as they can be. We do this globally. We have offices in Cardiff, in Ireland, in Australia, in the US, and we work with a number of different major manufacturers from different industries and in different formats. We work in things like food and drink, to major pharmaceutical plants, to right across into how you apply TPM even in things like financial departments, and understanding what that looks like. I say we work from different size companies, from single sites to multi-global national things. I'll let Andy take over and really talk about, I'm going to carry on myself actually, asset management through the application of TPM. What it's all about in real terms is about teamwork. These are some of the pictures of some of the stuff we've done in terms of the pharmaceutical industry on the left-hand side. The stuff on the right-hand side, you've got a picture of me and Andy up in Asia. The bottom one is in our utilities, but within the UK environment. So what's TPM about? There's a lot of misconceptions out there about really what TPM is all about. TPM is about establishing the correct relationship between our people to create and our equipment to create that ownership. And ownership is a real fundamental part of that. It's about unlocking our installed productive capacity of our potential of our people, by unlocking that potential of our people. And really, TPM is about maintaining that flow through our critical assets. Lots of people talk about flow and really don't understand what flow is all about. So it all starts in real terms, and everybody's familiar with the JIPM, set up by Nakajima in 1969, and really talks about the 5 founding principles. How do you increase the overall equipment effectiveness? How you improve existing planned maintenance systems? How you make frontline operator care part of the job and really understand, get people involved, talk about that ownership. How do you increase skills? So you develop the people and open up their potential. And how you cover early equipment management, and actually how that all links together. So they're the 5 founding principles that allow you to go. Andy, do you want to take over?
Yeah, okay. So we're going to take you through a couple of examples of the application of TPM in different environments. And rather than a typical batch processing or production assembly line process, we'll focus on the application of TPM in the utilities environment, specifically in a wastewater treatment plant, and the application in a laboratory in the testing of pharmaceutical products. And the key focus of the application will be the application and the measurement of overall equipment effectiveness in these environments. But we'll start, though, with a short video to level up our understanding of OEE as explained here by Peter Wilmot.
Chris should hopefully play the video.
If you are an operator on a typical manufacturing asset, if you like, a day in the life of, and to see how the overall equipment effectiveness actually...
The video needs to be shared on the screen, Chris.
Chris, we're not seeing the video.
You need to share your screen, Chris.
Videos.
Okay.
If you are an operator on a typical manufacturing asset, if you like, a day in the life of, and to see how the overall equipment effectiveness actually affects that person and his asset. So let's take a situation, as I'm going to draw up here, is that, and to keep the arithmetic easy, let us assume that I'm working a 10-hour shift, and I'm the operator of this particular asset that has a production rate, right, of 100 items per hour. So I come in, switch the machine on, and 10 hours later, I've had the perfect shift, and I have produced 10 times 10, 1,000 on time, in full, perfect products. In other words, my overall equipment effectiveness is 100%. Brilliant, absolutely brilliant. But the reality is somewhat different. When I come in to take over from my colleague Andy, who's been on the previous shift, I like to set this machine up to my own style. I know there's an operating instruction and best practice routine somewhere stuffed away in the drawer, but I know what's best for this. So I do a bit of tweaking on this asset when I come in at the start and slightly reset it. And in the framework of the overall equipment effectiveness, that is called a startup loss. I also know that if we run it at the standard cycle time of 100 per hour, the finish gets corrupted and is just not fit for purpose, this machine. So I wind it down to run at 90 units per hour, not 100. By doing that, I know that I'm protecting the quality. So I'm actually running it at a reduced speed, which is one of the other 6 losses, in addition to startup losses that are referred to that affect the availability, the performance rate, or the quality rate of this machine. And we're going along quite well, and suddenly I have to press the stop button and go inside the machine. I don't need a maintenance technician, by the way, but I just go in and jangle this pallet loader up and down because it gets jammed, and off we go again. We have a little startup loss, but nothing much there, and that's called a minor stoppage. A minor stoppage doesn't require my maintenance colleague, Martin, to come and fix something, but causes me to interfere with the process. And that, and similar minor stops, I can tell you, happens at least 20 times a shift, if not more. And we're going along, and this motor, which to my knowledge has been making a very loud noise, suddenly starts to smell of burning and goes bang. and we have a breakdown. Not a nervous breakdown, but I tell you, it's beginning to feel like this for me, the operator on this particular shift. So we suffer a breakdown, and that requires me to go and get Martin to come and fix it. Martin comes along, has a look at the motor that's burnt out. He goes down to stores. He comes back to recheck the part number because there's nothing in stores, because the part number on the motor has actually been damaged by a hammer at some point in the past. Anyway, he comes back, he goes down, and eventually he comes back, and we restart the operation again. Now, the point is that that breakdown was unplanned, and also in here, because we've had to completely clear out the system in order to repair that breakdown, we've actually produced quite a lot of scrap in there that has to be cleaned out of the system. So far, we've got 5 classic losses. We've got breakdowns that affect availability. We've got running at reduced speed and minor stops that affect the performance rate when we're running, and we get startup losses every time we get a breakdown. So there's another startup loss there. Every time we get a minor stop, and we produce scrap as well as that startup loss. And then to complete it all, the boss comes down towards the end of the shift and says, "Stop this job, Peter. It's time to do a changeover. We've got this customer telling us that if we don't deliver it, that's the end of it." So we have a changeover. And I think to myself, thank God it's time for me to go home, because I have not had a hassle-free shift. We've only produced production in there, right, in these parts here. So my overall equipment effectiveness, instead of producing 1,000 right first time items, this green bit says we've only produced 600 right first time items. You don't need to tell me through the fancy arithmetic that our OE is 60%. I know it is. I also know that I work a 5-day week there, so it's saying that me and my machine is only effective for 3 days of the week. If through this TPM process, this 11-step process that we've talked about, if we can use that, then if we could get our overall equipment effectiveness up to 80% by tackling all of these 6 types of losses, if we could get it to 80%, I'd be effective for 4 days of the week. I wouldn't have a hassle-free shift, but I'd be well on the way.
Okay, let's flip back to the slides. Okay, so let's take a look at the application of OEE in a wastewater treatment plant. And the asset that we will focus on is called the gravity belt thickener, okay, or the GBT, which is the primary function of dewatering sewage as sludge and treating it with polymer material to facilitate the thickening over a conveyor belt. Now, this belt then feeds the digester where all the magic happens to the sludge and is one of a number of key processes in the sludge workstream. And feeding of the sludge from the GBT at a constant flow and at the correct specification of water content or percentage dry solids is critical in order for the digester to perform at its optimum capability, as producing a dry cake, and that's not the confectionery cake kind here, but it's key in order to reduce logistics costs of transporting the cake. And also a byproduct from the digester is methane gas, which is captured and used to run the plant and also sold back to the grid. And the GBT performing at a good OEE will ultimately maximise gas production and optimise the logistics costs and ensure regulatory compliance. So the challenge for the team was, how do we measure the elements of availability, performance and quality on the GBTs? The quality element being an interesting one, as we can over-process the sludge, i.e. make it too thick, and we can under-process the sludge too thin. And both these scenarios will result in a negative impact on the digester performance, for example, more heating needed for thinner sludge. So let's just have a look at these working environments. So just to help you visualize the process, we've got some photos at the start of their TPM journey of the polymer feed area and the GBTs. And as you can see, not a pretty sight, with poly spilled on the floor, making it very slippy, covers off the asset, disorganized storage areas, a blower sat on the broken bung wall waiting to be installed. And the OE here is at 22%. In this picture here, you can see examples of equipment malfunctioning. This is the poly shear arm, which actually regulates the flow of poly to the GBTs. And then 20 weeks later, you can see a much improved environment. Firstly, the poly spills have been cleaned up and the leaks eliminated by changing the diameter of the poly feed pipe from the IBC. The yield from the IBC has been improved by putting on an incline. The bung wall has been fixed and the air blower has been installed, which has resulted in the noise levels being reduced dramatically to the extent that hearing protection is no longer needed. And again, you can see here the GBTs running at 74%, which meant the processing capability has effectively improved by more than 3 times. Okay, next. So what we want to do here is make the link of the measurement of OEE and the achievement of the percentage dry solids of the GBTs all the way back to the site objective of reducing operational expenditure across the sludge stream. And you can see that link there from measures to the objective. So next slide. So let's have a look at how the team went about identifying sources of data and measuring OEE on the GBT. So this is the way they did it, okay? So let's have a look at the availability. So, you know, as far as the 6 losses goes, is that, you know, the 5 foot, the belts didn't suffer, particularly from setups or changeovers. So the focus really is about looking at the data from the SCADA system on breakdowns. And although they were quite reliable, they did suffer from time to time with breakdowns. So the team calculated the breakdowns by registering the breakdown failures over 24 hours. And here we have an example here, the number of failures, and therefore the availability calculation giving us an availability of 91%. Next slide. This is the performance. So to measure the performance was a little bit more complicated, as the belt thickeners suffer both from minor stops and running at reduced speed. And the way the team did this is they assessed the sludge feed rate and then the amount of sludge fed over from the source of data being the flow meter. And as you can see here, the performance rate came out round about 48%. And then if we look at the next measure, which is quality, okay, by measuring the percentage dry solids coming off the belt, we knew that the target was 6.5%. And as I said before, is that we can over thicken and we can under thicken. And here we've got a calculation here based on 3.25 coming off and 9.75 coming off, which effectively gives you a quality rate of 50% in both those scenarios, as explained here. So when we look at this together, we effectively have a OEE of round about 22%. Okay, so that's just an example from a pharmaceutical environment. So let's now have a look at an example of TPM in a pharmaceutical laboratory environment, okay, and specifically the measurement of OEE. So in this case, we'll focus an example of the HPLC, the high pressure liquid chromatograph, whose function is, in very simple terms, is to take an injected sample dissolved in solvent and use chromatography to check the peaks of an output graph to ensure they are where they should be and to the correct resolution, and thus the sample is to specification. So, you know, as with assets in a lab, the OEE is about the effectiveness of the testing regime. But again, we have to consider how we measure A, P, and Q. So let's have a look at the pictures. So these are just some examples of the HPLCs at the beginning of the process. And as you can see here, worn bushes, a cover missing from the solvent bottle, and damaged ferrules. And the condition of the ferrule is critical to ensure solvent flow. Here we have more pictures from the HPLCs where the baseline OEE was 33%. The top left picture shows the solvent line not fully immersed, which could result in a bubble getting into the system that would result in the process failing and the test needing to be rerun. So let's have a look at, again, just more pictures later on. And let's have a look at the way they measured the OEE. So as you can see from here, this is the equipment utilised time for the HPLC. And you can see here that the team translated the 6 equipment-based losses to what these look like in their lab process. So waiting for the equipment to reach the right condition is a startup loss. Cleaning the equipment is a changeover. Other non-equipment related losses, such as waiting at the beginning of the receipt of the job order, reading the job, and preparation of the sample and the container. And in this example, N is the number of batches in the train to be tested. So let's have a look at these losses highlighted in red. As you can see there, we have waiting for condition, breakdowns. And then moving on to the next slide, as we calculate the availability, we subtract the downtime from the plan rate and we express that as a percentage of runtime. And then if we look at the next slide, which starts to look at our performance losses. Next slide, please, Phil. Okay. This shows our performance losses over this shows our performance losses of running at a slower than design speed, slower manual operations, if you just move the slide on, against the cycle time, and unrecorded minor stops. And minor stops where the equipment is adjusted for minor repairs of less than 5 minutes. And the net result is ultimately we only run of a batch of 10, we only manage to do 3 tests. If you just move that on, next slide, okay? And again. Okay, and as you can see here, the standard size of batches is 10. We were only able to run 3 batches. Okay, so let's effectively have a look at the next piece, which is the quality element of that calculation. So when we look at if we just move to the next slide, please, Phil, the quality. Okay, so when we look at our the number of batches we've run here, so during the runtime, we were only able to test 3 batches because of our performance losses. And if we look at the next slide, if one of those batches failed, okay, that effectively means we have only run 2 out of 3 batches. And again, just using the simple maths there, is that 2 out of 3 means that we've got a quality rating of 66%, okay? So that's the way the team went calculating the overall equipment effectiveness on the HPLC in the lab. If we move to the next slide, please, Phil. Okay, so we're just going to show you this best of best concept, okay? So we're going to take an example here of golf. So I'm sure that there's some golfers out there in the audience today. So let's just have a look at this as an example if we move this on. So if we look at a golf performance over, 4 rounds over the last 4 weeks, okay? And we were only looking at 6 holes here, guys, not and ladies, not 18 holes, but just looking at that, what we're going to do is we're going to select the best score from each hole. And then when we look at the average, okay, which is 32, and compare it to a par, which is effectively a very proficient or even you could argue world-class golfer score, you can see where the average is. When we look inside for the best score, our best of best is 25. And we use this concept when we are looking at our OEE. So if we just move to the next slide, Phil. So what we'll do is we'll look back at our OEE in terms of availability, performance and quality over, for example, a 4 weeks period of time, and then look at what the best availability, the best performances and the best quality is. Then compare it to the average, and you can see an example here. The average is 70% OEE. Then we look inside the availability, inside the performance, inside the quality. We get what we call a best of 84. And that difference between the best of best and the average is 14 percentage points over 70, which effectively is a 20% real improvement in productive capacity. And that's typically used as setting as a target, a milestone target setting. And this just articulates that 70% performance, achieving 118 productive hours per week against the 84, which gives us an additional 23 productive hours. So I'm going to hand back now to Phil just to bring this to a close.
Thank you very much, Andy. Much appreciated, and thanks for all your time. What we always talk to people about is TPM's a journey, both in terms of that progression as you walk through it and understanding what your asset management process is all about, and also an education journey. So we talk about, some things around a half-day awareness, understanding what the basics are. We talk about a 2-day masterclass, a 5-day practitioner, and a 5-day advanced practitioner, taking the theory more and more, and actually how you apply it within your business. As Felix mentioned right at the beginning, we write books on this. So this is the latest book we've written, which is the reason I invited Andy in today. He's a co-author of this. In terms of TPM, this is world recognised. It's up for the Shingo Award at the present moment. So if anybody understands the level of continuous improvement, that's the best of the best, and hopefully that will win an award. Thank you very much for joining us today, and that's us.
Okay, thank you very much, guys. Very insightful again. Something I used to practice a lot in previous life. Anyway, okay, so thank you. We need to go over to our next presentation, which is Chris Lakin from Beyond World Class. So we're a couple of minutes behind, so if we give you a few minutes to get over there, and we'll start reasonably soon. Okay, so please go to Chris's presentation now. Bye.